Hi students! Welcome to Practical Research 2. I'm teacher Nilsson. Our lesson today is Variables in Quantitative Research. Make sure that before you proceed watching this video, you're able to answer the pre-test. Activity 1, let's review in pages 14 and 15 of your module. Variables play a significant role in quantitative research. When you intend to accomplish something through research, the boundaries of your goal must be defined first to direct your focus into a specific characteristics or condition through identifying the variables of your research study. Doing such eliminates complexities and elaborate work, especially for a senior high school student like you. Knowing the different kinds of research variables also aids in smooth data collection and analysis. Variable or variables. What is a variable? A variable is anything that has a quantity or quality that varies, concepts which can assume different values. In this lesson, we will discuss three variables. We have independent, dependent, and extraneous variable. In understanding further the variables, let us consider the following expression. Y is equal to 3x plus 1. Note that the expression contains a constant 3. This one. The expression has a constant 3. And two variables, x and y. These are variables. Knowing that variables are concepts which can assume different values, see what happens to y as the value of x becomes greater or smaller, or we change the value of x. Suppose we assign 1 to the value of x. What happens to the value of y? Okay, a simple mathematical equation, simple mathematical solving here. We are just going to change x into 1. Okay, y is equal to 3x plus 1. Y is equal to 3, x becomes 1 plus 1. Y is equal to 3 plus 1 and y is equal to 4. So you notice that if x is changed, y changes. Let's try this one. If x becomes 2, or we assign 2 as the value of x, what happens to the value of y? What is your answer? Alright, this is how you are going to do. Y is equal to 3x plus 1. Y is equal to 3 times 2 plus 1. Y is equal to 6 plus 1. Y is equal to 7. Therefore, if x is equal to 2, then y becomes 7. I have a question for you. What happens to y as we change the value of x? Correct. The values of y depend on the assigned values of x. When we change the value of x, then the value of y changes. X here is an independent variable. In the expression y is equal to 3x plus 1, y is a dependent variable because it changes the moment we change the x. So it is dependent to the values of x. Let us have a more common example to understand further the independent variable and dependent variable. During quarantine period, your mother planted tomato seedlings in pots. Several factors are affecting the growth of tomatoes. We have the sunlight, water, kind of soil, and nutrients in soil. In this example, what are the dependent variables? Correct. The dependent variables are the growth of tomatoes and the number of fruits produced. Therefore, we can say that those which are affected or expected to be affected by independent variables are called dependent variables. In this example, in the same example, what are the independent variables? Correct. The amount of sunlight, water, and nutrients in the soil. Thus, we can say that independent variables are those that affect or is presumed to affect the dependent variable under study. It is important to note that there are other factors that may influence the outcome or the dependent variable, which are not manipulated or predefined by the researcher. What are these factors? They are called extraneous variables. They are factors which are not manipulated or predefined by the researcher. In our example, the presence of pests and environmental stressors. Example, the pets, extreme weather, they are called extraneous variables. Since extraneous variables may affect the result of the experiment, it is important or crucial for the researcher to identify them prior to conducting the experiment and control them in such a way that they do not threaten the internal validity or accurate conclusion of the result. Since extraneous variables may affect the result of the experiment, it is crucial or important for the researcher to identify them prior to conducting the experiment and control them in such a way that they do not threaten or affect the internal validity. Example, the accurate conclusion of the result. Controlling the extraneous variable can be done by holding it constant or distribute its effect across the treatment. When the researcher fails to control the extraneous variable, that it caused considerable effect to the outcome, the extraneous variable becomes confounding variable. For example, if the tomato had been infested by pests, pest here, confounding variable, then you cannot conclude that manipulations in sunlight, water, and soil nutrients, which are the independent variables, are the only contributing factors for the stunted growth and poor yield, which are the dependent variable of the plant, or is it the result of both the independent variables and the confounding variables? The variables can also be classified according to their nature. Here's the diagram. Variable, under it, quantitative, numerical, and qualitative. Under quantitative, we have discrete, continuous. Under qualitative, we have nominal, ordinal, and dichotomous. Quantitative variables under it are the numerical variables. We have A, discrete variable, and B, continuous variable. Discrete variable. They are countable whole numbers. They do not take negative values or values between fixed points. For example, number of students in a class, group size, and frequency. If someone asks how many students are in TVL, you cannot report and say 44.5 students or 44 and a half students. Continuous variable takes fractional or non-whole number values that can either be positive or negative. For example, the height, temperature. There exists a continuous range of values from the smallest to the largest possible amount and measurement. Under qualitative variables, we have here internal and ratio. Interval, the distance between the points or the interval scale are equal. For example, the difference between 36 degrees and 37 degrees is the same as between 100 degrees and 101 degrees. Let's take this example, the IQ test score bell curve. If you notice, 55 to 70 mentally inadequate, 70 to 85 we have low intelligence, 85 to 100 below average, 100 to 115 above average, 115 to 130 high intelligence, and more. So you notice that there is an equal. Okay, the distances between points or the interval scale are equal. So this is a good example for interval. We also have the academic achievement and personality test score as examples for interval. Let's move on to ratio. Ratio is similar to interval. The only difference is the presence of a true zero value. Examples are we have measures of length, width, height, weight, area, volume, age, distance, and other similar measures. Moving on to qualitative variables. These are referred to be categorical variables which are not expressed in numbers but are descriptions or categories. Take note of that. We have dichotomous and nominal as well as ordinal. Dichotomous. It consists of two categories or values. For instance, we have gender. Gender is considered a two-category or dichotomous variable. As such, we have male or female, so two. It is also possible to dichotomize the variable religion. Despite we have so many religions in the world, yet we can dichotomize it. How? You may say Catholic category and the other category will be non-Catholic category. Also, if you are a Bisaya, the other variable for ethnic group is non-Bisaya. So there are two. So we have just dichotomized it. So dichotomous consists of two categories. Nominal may be assigned numerical codes in order to identify the member within a given class. In here, you may have more than two categories. Example, marital status. We have here four. One for single, two for married, three for widowed, and four for separated. You could also have another example is the hair color. You see, hair color, one, brown, two, black, three, blonde, four, gray, and five, others. So you notice that it is more than two. So that is nominal. Other examples include blood type, mode of transportation, basketball players' number. Next, we have ordinal, those that may be ordered in some way, from highest to lowest or vice versa. For example, a survey questionnaire may have a numerical rating with choices like 1, 2, 3, 4, and 5. 5 as highest and 1 as lowest. Categorical rating like strongly agree, agree, neutral, disagree, and strongly disagree are under ordinal. Look at this example. This is an example of an ordinal. This is a revised attitudes toward research scale by Elena C. Papanastasio. The instruction, please rate your degree of agreement or disagreement with each of the following statements. If you are among those who will answer this, you will notice that you are asked to rate each statement. Example 1. Number 1, research courses make me anxious. So maybe you may say strongly agree. So you have at least 7 choices. Another example is the academic honors. We have with highest honors, with high honors, and with honors. So there is a certain rank. That is why it's called ordinal. Let us consider this question pro from question pro, the ordinal data. Okay, we have here from hot to hotter and hottest. So there is an order. That would be all for this session. I hope you have learned a lot. Also, you answer the activities in pages 17 to 23 of your module and the My Learning log of this video. God bless.